So the idea was we want to develop psychophysics, which the idea is that this is an early identity theory. The idea is that is a surface to better surface. Is it convex or concave? And the idea, like this, like that. Is this concave or is it convex? You see what I'm saying? And the answer is, it depends what you're looking at. Let's say you're inside a sphere. The sphere will look to you concave because you're inside of it. So an outside observer will look convex. Yeah. So which one is it? And what he says is a matter of perspective. So all you have to do then, as with psychophysics, is you make a functional link in literal functions, like a mathematics. He was a physics professor. He was like, all I have to do is to map the functional relationship between the inside quality, like the qualia, you'd say, and the outside quantity. So I have to quantify that. And then I mapped it and I'm done. Then I showed that psychophysics is real and that this theory of soulfulness is real. And by the way, the reason he did that, I forgot to mention this, he initially wrote some tracts about the soul life of plants.
Mana, he called it.
Correct. Nana, the soul life of plants. And he thought what he says is like a revelation. It's like obvious that he's right. But the philosophers just made fun of him. They're like, come on, like what are you talking about? There was two schools of thought, the materialists and the idealists. They thought he had gone crazy, right? So ironically, he then developed as a way to demonstrate the veracity of his theory, psychophysics, which is ironically a method we still use today in psychology to do that. Like remember, he still didn't have screens when he published in the 1860, the elements of psychophysics. So he did weights. So the idea is that I ask you how heavy something is in relation to something else, and there's a precise functional relationship between how heavy you think something is and how heavy it actually is, because you can weigh that. They did have scales, and there's the Fechner limit, for instance. Like if you add 10 grams to a kilogram, you might not perceive that, even though 10 grams has been added to the kilogram. Yes, whereas if you add even 1 gram to 10 grams, you might notice a difference. That's a just noticeable difference. So he mapped out this functional relationship between objective stimuli. And then they did this with pain and classically...
light.
Later. They didn't have screens. Light came much later. It was more like I poke you with a circle, like so two prongs. And the question is, how far is the distance as a function of where in the body it is for you to perceive it as one? For instance, your back, you can be quite far away, like so far, and you will still only feel one prick. Whereas your lips and your fingers are very sensitive, like millimeters, even less. So they mapped out the whole body. His assistant, they poked him all the time, like 10,000 times more. Yeah.
There's so much to explore here. Firstly, all those philosophical digressions. He penned in, no, not you, Fechner, penned in his book, Zen the Wester, on things of heaven and the hereafter from the standpoint of natural observation. But
so the irony, just to jump in there, the irony is that he had this, after this insight, he had this scientific publications, his books, again, and all that is still used today. It's still called psychophysics, by the way. You can be a psychophysicist today. I myself, as you know, have done quite a few psychophysics experiments. But he had a second thing that he actually cared about, which was these philosophical implications of that. And that didn't go anywhere. That is not a thing people believe today, which is actually very sad, but it is what it is. That did not catch on in philosophy, as far as I can tell. Anyway, I'm sorry to interrupt.
Not at all. You can take as many interrupts as you like. You have full liberty. Let's explore the science first.
Yes, sir.
Let's dive into psychophysics. So you already brought up, it's a relationship between a stimulus and your perception of it. So I really want to break it apart. Let's say
let's be clear. I want to be clear. There's two versions of this. One is external psychophysics. That's what you just did, which is the outside stimulus, which I have control of as the experimentalist. As if today I can set the lighting and the sound and whatever to whatever I want. I can describe light and sound, with wavelength and amplitude and frequency very precisely. With modern lighting systems, you have complete control over the stimulus. The wavelength, you can use lasers. It's amazing, yes? And then you just ask people, let's say I make it this bright. How bright do I have to make it for you to be perceivable at all? That's
What's the threshold?
The threshold method. I was just going to say that, yes. And that's actually quite interesting. So later people showed Piren, Schlecht, and someone else in 1940s that people basically can perceive individual photons.
Really?
I can send you the paper for your show notes. I'll send you the Hecht, Schlecht, and Piren paper, 1940s. They use psychophysics methods showing that people can perceive individual photons. It's that sensitive. Yes. I mean, they showed 7, but statistically you can then show that if we can detect 7, that probably means it's 1 if you do the math. I'll send it to you.
This is a good point to introduce Fechner's law. Let's say there's a light bulb and I linearly increase the intensity of it. Does my perception also increase linearly?
No, it's log scale. That's one of his big insights. It's a log transformation. I mean, I don't think he knew why, but we know today it's because of orders of magnitude. Basically, you need to be able to look at the sun. Don't do it too long, which is very, very bright, 100,000 lux or more, yes? Whereas in indoor lighting, you might be at 1/10 of a lux, yes? But interestingly enough, you might not realize that, if that makes sense, because we use the light just as an illumination source. We don't care about the light itself. We see how light illuminates objects so we can recognize the objects. But that has to work about a very large range. Broad daylight, sunlight, 100,000 plus lux, and like maybe a dark forest at dusk, and you still have to see something. We can navigate and see things. So your vision has to work, I'm going to say, between 6 and 8 orders of magnitude of lighting levels. That range to linearize, it has to be log scale. To have that many units of resolution in there.
Do we know why?
Well, for evolution, for survival. So basically, if your light only worked in like daylight, that'd be problematic, yes?
Yeah.
Although some animals have two visual systems, one for night vision and one for day vision, like cats, for instance.
Yeah, but why doesn't that perception not change linearly? Why does that change log?
It can't. It would all be compressed. You wouldn't be able to tell. That makes sense. Like most light levels would all be. You would not be distinguishable. It would not work like that. You have to log scale it. Otherwise, you don't have a linear range of perception. So in other words, a linear scale in physical stimulus, which is irrelevant, has to be transformed to a linear scale in perception by the log transform. But you want the perception to be linear, not the light to be linear.
And that's not possible. Yes.
No, you cannot have it both ways. You would. It wouldn't work. Yeah, you would all be. Most stimuli would all be so close together you couldn't distinguish them because it's such low light levels. But anyway, everything we just discussed is external psychophysics. And by the way, in Fechner's own language, what he wanted to do but didn't have the technology for is inner psychophysics, which is mapping the neural response to the perception. So basically, there's 3 levels. There's the outside stimulus. There's the neural response to the stimulus, and then there's the experience which is given rise to by the neural response. And he could only do, in his own mind, outside psychophysics. Modern cognitive neuroscience is inner psychophysics. It's like mapping the neural activity to the
perception of it.
Yes, correct.
So how does that happen? Let's say I perceive a light source. What's happening in this second to third stage?
Well, how much time do you have? I mean, we actually understand this part excessively well. Every detail of it. I did my PhD in this. I'm not the only one. I would say visual neurophysiology is probably the most advanced. No hate to any other fields of neuroscience, but the most well-developed field. We have to a functional level. I can write down the functions, how the neurons transform this stimulus into that stimulus. Early on, for instance, they do a Fourier transform of the stimulus. It's amazing, actually. And I will happily send you for your show notes some of the papers that my colleagues did, that I did, where we mapped out this functional relationship between the outside stimulus, the neural response, and the individual perception. But briefly, since you asked, the light source emits photons. Can be the sun, can be light, can be whatever. It bounces off the surface. Let's say this is blue. Yes. So the reason this is blue is because this absorbs middle and long wavelengths and reflects short wavelengths, which goes right then. So it bounces off and that's absorbed by the photoreceptors in my retina. There's 3 of them that are relevant right now: short, middle, and long wavelength. If this is blue, the ganglion cells that encode this short wavelengths, so there's different ones, it's magnocellular ones, it's powercellular ones, send that to what's called the thalamus, the LGN, the visual thalamus, the LGN, the lateral geniculate nucleus, which is a relay station, also a gating station, which sends it then to the primary visual cortex in the back of the head, so area 17, area V1, the primary visual cortex, where a Kantian categorical analysis of the stimulus takes place. What does it mean is that that Kant was right. Kant was like, you have to understand the world. There has to be an analysis. Where are the edges? Where are the horizontal lines? Where are the vertical lines? Where's the motion? Where's the colors and all that? Before any objects, just fundamental categories. Horizontal, vertical, and all
Cluster
that.
them into categories.
Yes, categorical analysis of the environment. That happens in V1. Hubel and Wiesel won a Nobel Prize for that. I think Wiesel might still be alive. Hubel died. But Hubel and Wiesel in 1981 won the Nobel Prize for showing that primary visual cortex effectively performs a Kantian categorical analysis. So these neurons get activated by, say, only horizontal lines, some neurons. Others only by vertical lines and everything in between. Okay? Others only for short wavelengths, middle wavelengths, and so on. So it's like a clustered, categorically clustered. It's very interesting. It's both categorization and clustering of the image. And then those neurons send projections to higher level visual areas that then build up hierarchically, like a CNN in a modern convolutional neural network. One after another, convolutional layers.
What is a CNN?
A convolutional neural network, which performs a convolution operation on the inputs.
What does that mean?
What does it mean is it depends what the convolutional kernel is. So the idea is that, again, how much time do you have? But let me just try to break this down briefly. Let's say you multiply two numbers. When is the product the largest? And the answer is if the numbers are equal. So 5 times 5 is 25. 6 times 4 is 24. 4 times 6 is also 24, right? 3 times 7 is 21. So if you have 10 units to distribute, that's going to be maximal if it's 5 and 5, yes?
Right, the square.
The square. That square is going to be the max of that function. And the convolution operation utilizes that by making that into a universal pattern detector. Imagine your neurons have what's called a kernel as a filter, and they have some weights. We call that in neuroscience the receptive field. And that neuron is going to fire maximally if a light pattern falls on it that matches its numbers, right? So you have a pattern detector. You could detect, let's say there's a single 1 in the center and all zeros around it. That's going to be fired maximally if you see like maybe a fly or something like that. That's just hitting this one neuron, right? Or whatever pattern you're looking for.
That's fascinating.
It's fascinating, right?
Yeah.
And anyway, but that's built up later. So you have originally in V1 you have these fundamental lines, horizontal, vertical. Then V2 you might have. I'm glad you brought those Legos. Although I'm not as good at using them. Let's see. So in V2 you might have neurons that are sensitive to angles, like this or like that or like this.
So those would fire if I see something with angles?
That are like some kind of intersection, yes. But very specific, some for right angles, some for oblique angles, or whatever the angle is, yes? And then they later project, let me see, I can do this, to neurons that might recognize shapes.
A circle, maybe? Could be.
Or toothbrush, or square. No, I got it. Oh, there. But that's not built up. I need to build it up. And then so on. And then this projects to neurons later that recognize whole faces and so on. It's a hierarchical structure. And if you look at these, and you know what, for your show notes, I'll send you the paper. Honestly, it looks a lot like a modern CNN. As a matter of fact, Jan Lacan got his inspiration for that from neuroscience. I don't have to guess. He said so. You know, he told us that. So there is virtue in our Fox Lab philosophy to connect fields together, right? The idea of a CNN didn't come from computer science; it came from neuroscience. That's what we think the brain is doing. And I will happily send you this for your show notes. These papers.
So this is all evolutionary adaptation?
We think so. I mean, one thing, and I think we talked about this in our first round, it is my strong belief that you do not see reality unfiltered, or we have no idea what reality is. You
said objective reality is scarily unknown.
Yeah, but it could be anything. It could be anything. What you're experiencing, as far as I can tell, if I grant you that you have consciousness, because I have consciousness, is an interface that is evolutionary adaptive. It's like an operating system, but you don't know what's going on under the hood. You know what I'm saying? There's layers and layers and layers of abstraction, all filtered by 1 billion years of evolution. So who knows what's going on under the hood? It's like what's going on, I don't know, this is Mac, yeah. What's going on in your Mac operating system has no relation to the layers and layers and layers and layers of what's going on in the electric, like the currents are flowing on a chip. At some point, currents are flowing on your chip, but there's many layers of abstraction between your operating system and so consciousness is your operating system on reality, and it's a interface that, in my opinion, is very far removed from. And this is why, as you know, some people take drugs to like hack the interface and go deeper into the matrix, so to speak.